Welcome back after the break, and we look at figure 1.5, and what we basically see is a river that's dry, no water during the dry season, and we got running water in rainy season. And let's quickly have a look at the question that follows. So we basically clarify that this is a non-perennial river, but let's quickly go and have a look at the questions that follows. Name the type of river in the photograph, and we can mention that it's a non-perennial river, or we can say what you've learned this year, a periodic river. Okay, provide evidence from the photograph to support your answer to question 1.5.1. As you can see, the water level changes. The water level changes during the course of dry season, the dry and wet season. So basically, if you look at it, when does it flow? Only during wet season. So seasonal rainfall. During the dry season, let's say for instance, let's assume this is in the interior of South Africa. During winter months, the river is completely dried up, but during summer months, the river will flow. If you look at our next question, define the term water table. It's the upper layer of the underground water surface. Okay, where do we find the water table? Below the surface. It's usually where the water infiltrates to. Now, if we had to draw two labeled diagrams to show the different positions of the water table in the dry season and the rainy season. So this is quite simple. Now basically, I'm going to draw a transverse profile of my river bed. Now this is river A, and this is river B. So what do we know about river A? River A is during dry season. There's no visible water in this river bed. If we look at river B, what do we see during rainy season? There is water in the river bed. So if I had to go and draw in the water table, during winter, the water table is well below the surface of the river bed. But during rainy season, what happens with this water table? It rises. So we can actually see physical water in the river bed. Now, in a paragraph of approximately 8 lines, explain the influence of precipitation. Now, precipitation can be hail, snow, rain, and the gradient on the amount of deposited material evident on the river bed. Now, precipitation, now what we're basically having a look over here, we're going to discuss precipitation separately to the gradient, but both of them plays a huge role in the amount of sediments that's being deposited down in the lower course of the river. Now keep in mind, when we look at precipitation and gradient, also keep in mind the density of a drainage pattern and a drainage density. Now the density increases, for example, when there's more precipitation. There's going to be greater volume of water. And the density also increases when the gradient is steeper. Now the density of a drainage basin decreases when the gradient is gentle because it gives time for infiltration. And obviously the density is going to be less if there's not a high rainfall or high precipitation in area. Now just before I'm going to continue answering this question, when I refer to high density and low density, if this is a drainage basin, and it's got a lot of tributaries, we say it's a high density. If we have a drainage basin with only a few tributaries, we say it's a low densities. But let's quickly go and look at the answers, and let's start with precipitation. So the question asks, explain the influence of precipitation and gradient on the amount of deposited material. So I'm going to start with precipitation. Now, first of all, in the dry season, there's low precipitation. Resulting in low river discharge. Discharge is the load that the river carry. For instance, there's discharge coming from the upper and middle course. The upper course, remember, is vertical erosion taking place. The middle course, we've got lateral and vertical erosion taking place. What happens in the low course? Deposition. But keep in mind, this river is only going to be discharged in rainy season because there's no water in the river channel. So what else can we write over there? Now, the carrying capacity of the river is low and deposits the material. Okay. Carrying capacity is low to deposit the material and deposits the material. Now, if there's going to be volume of water, for instance, in the rainy season, the carrying capacity is going to increase because there's water in the river channel. And then, if we look at in the rainy season, what's going to happen? Rainy season, greater volume of water. And there's going to be erosion because of greater volume of water. Now let's quickly go and have a look at the gradient. Now remember what I said, if the gradient is going to be steep, it's going to be high density. So if you look at gradient, a gentle gradient reduces the velocity. The velocity of the river. So it means it's going to flow slower. Okay, and if we look at the steep, a gentle gradient will eventually lead to more deposition. Our deposition is basically dumping the material that's been eroded and weathered in the upper and middle course. So because of the gentle gradient, the velocity of the river is going to decrease. Now if you look at one of the characteristics of the low stage of the river, it kind of flows sluggishly. And what happens? Braided streams develop as well as meandering because the river is flowing very slowly because of the velocity has decreased. Right, let's quickly go to our next question. Refer to figure 2.4 showing anticyclones over southern Africa. Now what do we have with anticyclones? Now what is an anticyclone? First of all, we need to go and have a look at that. An anticyclone is a high pressure system. And what do we know about a high pressure system? It moves anti-clockwise in the southern hemisphere and it's subsiding air. Now if we look at figure 2.4, South Africa is situated on the 30-degree latitudinal position. So there's the 30-degree latitudinal position. Now if we look at primary circulation of air, what do we know? We are being dominated by the subtropical high pressure belt. And as you can see, three high pressure systems that dominate South Africa's climate situated there. Look at the anti-clockwise circulation of air. The first one that we have over here is the South Atlantic high pressure system. Okay, then over the interior of South Africa, number B, is known as the Kalahari high pressure system or anticyclone. And over the Indian Ocean, we have the South Indian high pressure system. Okay, below, as you can see, we got a mid-latitude cyclone traveling from west to east, moving in the westerly wind belt. There you can see one of the characteristics is the cold front. We don't usually see the warm front because it's too far down south. It's a low pressure system. So what I want us to do is just to concentrate on this subtropical high pressure belt. As you can see, there's three high pressures dominating South Africa's climate: the South Atlantic, the Kalahari high, usually only during winter, and the South Indian high pressure. Now let's go and have a look at the questions that's being asked. Name the high pressure cell labeled B. And that one is the Kalahari high pressure system. Now, why does high pressure cell B dominate the interior of South Africa in the winter? Now, if you look at the question over there, as you can see, it's only present in the winter, because what happens in the winter, we experience low temperatures. We experience lower temperatures in the winter. And there's a stronger subsidence happening in the system because there's less heating. Taking place. Now, if you look at the next question, give a reason for the lack of rainfall associated with high pressure cell A. Now, let's just quickly go and have a look. Now, high pressure cell A is the South Atlantic high pressure. And unfortunately, where this pressure cell is situated is over a very cold ocean known as the Atlantic Ocean, and we got a cold ocean current coming from the polar regions, the cold Benguela current. Now, even though it's summer, because the system is over a very cold ocean current, it creates cool and dry conditions. But if you look at the South Indian high pressure system, it's over the Indian Ocean, and warm water comes from the equatorial regions in the form of the Mozambique current. So that creates more moist conditions, and we need moisture for rain. So let's just quickly answer that question. 2.4.3. Now, as you can see, it's located, first of all, it's located over a cold ocean. And secondly, we're dealing with high pressure systems over here. The air is physically sinking, it's not rising. In order for rainfall to fall, what do we need? We need low pressure systems. We need rising air. Now, how does air rise? When air is being forced to rise, for instance, mid-latitude cyclones, the cold air forces the warm air to rise, or because of warm conditions. So, mainly, there's no rainfall associated with it because it's situated over a cold ocean. And the second reason is because it's subsiding air. Taking place, and it doesn't release moisture. Okay, if you look at our next question, explain the change in the position of the anticyclones over South Africa between summer and winter. Excellent question. Let's quickly go and have a look at it. Now, if you look at the synoptic chart, now basically what happens, this is definitely a synoptic chart. This figure is showing, not really a synoptic chart, but it shows us the anticyclonic circulation taking place. Now, first of all, this is definitely, it represents winter, because the Kalahari high pressure system is present over the interior. It can't be present over the interior because we experience low pressure because of warm conditions. The South Indian and the South Atlantic is quite stationary, but they migrate north and south because of the ITCZ. So what basically happens, in the summer, the South Atlantic tend to move down south. So what does it do? It blocks out the mid-latitude cyclones that create the Mediterranean climate in the Western Cape and rainfall for the winter. So that's the reason Western Cape experience beautiful conditions, no rainfall usually during summer, because this South Atlantic high pressure has migrated towards the south. Now the same with the South Indian high pressure. It migrates north and south, and that creates the rainfall because we experience low pressure over the interior and we experience onshore flow because of the South Indian high pressure, and the warm moist air flows towards the low pressure and creates the summer rainfall that we see over the interior. But let's quickly write what I've just mentioned in bullet formation. Okay. So we can say in summer, due to intense heating of the interior, interior is in the interior of Southern Africa, of the land, an interior of land, the high pressure systems move further out to sea. And basically what happens in winter, they are closer, and I'm talking, when we talk about they, I'm talking about the three high pressure systems. They are closer to the land because of colder temperatures. Okay, and that's the reason the movement of these subtropical high pressure belts between winter and summer. Stay tuned, we're quickly going for a short ad break. See you in a bit.